We're talking about the midpoint of a line segment, and I'm going to give you this key opening statement here of what midpoint even is. The midpoint is the point that is exactly halfway between two endpoints on a line. I hear a lot of whispering. I'm not sure where it's coming from, but I'm guessing of where it could be coming from. So yeah, just make sure you're quiet so you're not distracting anyone. So this is something you need to get down, super important, because it will guide what we're doing today. All right. The midpoint is a point that is exactly halfway between two endpoints on the line segment. Let's break this apart. Does anyone know what a line segment is? A line segment. Matt?
A segment of a line?
Yeah. What's another word that you can replace segment with? There you go. It's just a part of a line. So haven't we been graphing lines? And do lines have beginnings or ends? Beginning or an end at all? Do they? No, but does a line segment have a beginning and an end? So there's a difference there. So today we're talking about line segments. And then line segments have what we call, and I kind of already alluded to it, end points. So we call the 2 points where they begin or end, and you can say either one is a beginning or end. Those are called endpoints of a line segment. And we're looking for the midpoint, which you're like, okay, what does that mean? It's the point that's exactly halfway between those endpoints. Okay, we're talking about a line segment, so a part of a line. Has a beginning and an end. We call those points endpoints. The goal of this lesson today is to find the point that is exactly in between those two endpoints. And let's look at an example to figure out what we're actually doing mathematically. Okay, in order to find the midpoint, we're going to use a little formula here. They're going to give you 2 points. Okay, they're going to give you 2 points in this format. X sub 1, y sub 1, and x sub 2, y sub 2. So they're going to give you 2 endpoints. That's the beginning and the end of a segment. All right? And in order to find the midpoint, so the midpoint, excuse me, thank you guys. In order to find the midpoint, it's a pretty complex expression that we're going to look at. Okay, ready? So to find the 2 coordinates of the midpoint, right? The midpoint is a point, by the way, which means it has an x and y value. Okay, so in order to find the x value, you're going to do this. You're going to take the x sub 1, and you're going to add the x sub 2. Then you're going to divide it by 2. Which is doing what? What is that process where if you add 2 numbers and divide it by 2, you get this number? Carson? Yeah, what's that word we use to find the number right in between 2 numbers? Maggie? It's the average. That's all we're doing? Oh my goodness, wow. When you add 2 numbers together and you divide by 2, you're finding the average of the x values. That's all you're doing. So does anyone know how to find the y value for the midpoint? How do you find that y coordinate here? Emery? Divide by 2. Look at that. You're finding the average of the y coordinates. And that's it. The end. That's what you do. Okay, so let's now use it on an example. And we'll talk about that example because maybe some of you are thinking, Mr. A, hold on. I mean, shouldn't you just, is it possible to just, okay, and I'll answer some of those questions. Yes, Lily?
Is this just the first part of the get harder.
What do you mean by first part? How about this? Let's start off with this. Page 372. Page 372. We're going to look at number 4 on 372. We're going to go back to those examples later because they apply it to geometry. But on example number 4, find the coordinates of the midpoint of a segment with each pair of endpoints. So they give me 2 endpoints. They give me A. A is 5 and -2. And they give me B, and that is 5 and 8. And so they want me to find what is that midpoint. I don't know what the midpoint is, but we can figure it out by doing this process. All right, I want to find the x-coordinate. So you're going to do it on your work x-coordinate. And I have to add the 2 x values. So we're going to add 5 plus 5, and then do what to it? Divided by 2. And that's going to get me my x-coordinates. So what's 5? I'll put it like this. What's 5 plus 5 divided by 2? Good recovery. But what is the average of 5 and 5? 5, right? Oh, that's what we got. That's the average. Good. All right, to find the y-coordinate, you're going to do the same thing, but with the y coordinates from the endpoints. So you're doing -2 plus 8, and then divided by 2. So what's -2 plus 8? 6 divided by 2. And that's going to give me my y-coordinate, and we found it to be 3. All right, listening very carefully. They gave us 2 endpoints. They gave me the beginning and the end of a line segment. And what did we find?
The midpoint.
Which is what? What's the midpoint mean? The point that is exactly halfway between those points. Okay, so this is all like, okay, great. The process is pretty simple. But I want us to draw a little sketch to see if this is really even the case. So draw a coordinate plane, and it should look something like this. It should only go out to 8 on the y-axis, positive 8, and then 5 on the x-axis. Okay, I want you to put the 2 endpoints. So I want you to put where A and B should go. So A is, I'll put it here. A is 5, -2. So 1, 2, 3, 4, 5, -2. All right, 5, -2. And then the other endpoint is, and I'll put A here. The other endpoint is 5/8. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. All right, and that's point B. And then connect them with a line. All right, so that's your segment that we're talking about. And what were we trying to find here again? We're trying to find the midpoint. We're trying to find right in the middle, which would have been 5, 3. 1, 2. And because my drawing is not to scale, it's something like that. Okay? But I have a question here. Maybe some of you have it as well. Mr. A, couldn't you have just taken a ruler and put it right here? And then find what's right in between those 2 points. I mean, isn't that possible?
Yeah, but you never had a ruler.
Okay, and what if you had it all the time? Like, can't you just do that? Like, I have a ruler. I could just let you borrow it. But it's kind of big. Okay, why can't I just do that? I mean, that will get me my answer if I measure from here to here and then divide it by 2. Jackson? No, I would say if you can measure it out and you can figure it out halfway, that's pretty good. That's not it. Yep.
It takes too long. Sometimes the line is too long to measure.
Okay, it could have been that this line was too long. I know this is a big ruler, but like your rulers are only a foot long, if you get it, and that might not be enough. And what else? Do you want to add, Claire?
Well, like you might have a number and like a half or whatever, or something. So it might not be exactly like this. It might be like 5 and 3 1/2.
Okay, yeah, 5 and 1/8 might be an answer. You might be able to, when you're measuring it, you might get 5 and 1/8, and you might be off because you know what happened? These guys, they failed you. I thought it said 1/8, but it was actually a 4th. And so you messed up because you couldn't see well, or you know what happens? You measure it, and then you find out, oops, I divided that by 2 the wrong way. I didn't do the division right. It's a lot easier just to get the 2 points, get the x values, and get the y values, and average them out. This will get me my midpoint every single time. I don't even have to draw this out, and that's actually very useful because you're going to have to do several of these, and I don't want you to draw these out. They could take time. All right, let's look at, how many of you get this? You think, Mr. Come on. All right, number 7. Get me number 7. Get the midpoint of GH. No, don't draw any more graphs. Just find the midpoint of G and H. I want what's the middle point, or the point exactly halfway between G and H on number 7. All right. I need an ordered pair that would designate the midpoint of those 2 points. So what'd you get for your x coordinate, Jenna?
Wait,
-6. What's -9 plus -3? -12. Divided by 2? -6. And then what's your y coordinate? We got the y coordinate. Nate? You got 1. What's -6 plus 8? 2. 2 divided by 2? 1. Positive 1. Okay. How many of you got -6, 1? Okay. So without even graphing these points, can you find the middle of the 2 points? Mm-hmm. And you're like, that's really nice, Mr. A. Cool that we can get it down. What in the world is it used for? Let's go back to example number 1. So this is the geometrical use, or one of them. This is just one of the many. And can someone read a tougher problem here? Like, it's just a little harder to say. You're confident you could read it? Okay, I see that hand. Okay, Emery, go ahead. Carefully, please read it. Mm-hmm.
If the vertices of parallelogram yxyz are y30, x93, y710, and z17, prove that the diagonals bisect each other.
Prove that they
intersect at the midpoint.
Okay, so that was a handful. Example number 1, they gave you a parallelogram. Does anyone remember what a parallelogram is? Can someone kind of give me, what's a parallelogram? Specifically a type of shape that does this or has that. Anybody? Nate? Okay, a rectangle is a type of parallelogram. But so is that diagram right there. That doesn't look too rectangular. Doesn't have right angles. Yep.
It's a shape with more than 2 parallel lines.
Okay, listen up. It's a quadrilateral, which means it has 4 sides, that has 2 pairs of parallel sides. Okay, look at that diagram there, because they put it up on the coordinate plane. Do you guys see segment ZY?
Yeah.
Segment ZY is parallel to segment WX. Okay, is that a pair of parallel sides? Yep. What side is parallel YX? ZW. That's another pair of parallel sides. So does it have two pairs of parallel sides? Yes, that's a parallelogram. A rectangle is a parallelogram. A square is a parallelogram. A diamond can be a parallelogram. Where? The two ones in the inside? It looks like it. And we can talk about how we can prove it or not in just a moment. Okay, do you guys remember what a diagonal is? Can you guys tell me which lines are diagonal in that diagram? What color are they? The pink lines, right? The pink lines. You guys see those diagonals? Do you guys see segment YW? That's a diagonal. Do you guys see segment ZX? That's a diagonal. What's the whole point of this problem? They're asking you this. Those two diagonals, those two pink lines inside, do they intersect to where you cut both of those diagonals exactly in half? No. That's what they're asking. And you have to prove it. This is how we're going to prove it. Let's look at diagonal. So go ahead and write this down. Diagonal. We'll start off with ZX. ZX. Diagonal ZX. I want to find the midpoint of ZX. So what are the coordinates of Z? Anybody? Just say it.
1, 7.
All right, 1, 7. And what are the coordinates of X?
9, 3.
9, 3. I want to find the midpoint. Find me that midpoint. What is the point that is halfway in between Z and X? Okay. Matt, what's your X coordinate? 5. Oh, 1 plus 9 is 10 divided by 2 is 5. What's your Y coordinate, Rosalind? 7 plus 3 is 10 divided by 2 is 5. So the midpoint of ZX is 5, 5. Okay? Right at 5, 5. Okay, listen carefully. If 5, 5 is the midpoint of ZX, doesn't it cut ZX right in half? Doesn't it cut it right in half? That point would cut it right in half. Okay, do you guys see that word bisect? Does anyone happen to know what the word bisect means? Bisect. What does bi stand for?
Where 2 things intersect.
2. It stands for 2. Does anyone know what sect means? What does it mean to intersect, bisect? It means to cut. Cut into. And in this case, in geometry, it means cut into 2 equal slices. So does this point... So I'm okay with you sitting there, but if we can't handle it, then we'll have to change. But right here, does this point bisect this segment? Yeah, it does. Okay, so we have that so far. And now I want to know what's the midpoint of diagonal YW. I want to know what the diagonal of YW is. So Y... I need the ordered pair. And W, I need that ordered pair. So what's 7, 10? And W?
W is 3, 0.
Okay. Find the midpoint of these two. Okay, Jack, what's your X coordinate?
It is 5, 5.
X coordinate is 5. What's your Y coordinate?
5.
Alex. 5. All right. Oh, whoa. They have the same midpoint. Okay. Does this midpoint cut this diagonal in half? Okay, so now you have one diagonal and another diagonal. and they both are cut at the same spot, and do they form bisectors? So do you cut them into equal halves for each diagonal? And the answer is yes. So you just proved that they intersected to form to where they bisect one another. By the way, whoa, is that point there where they intersect really 5, 5?
No.
Check it out. I don't know. Check. Is that point where they intersect? Is it really 5, 5? Wow. It is. So that is the midpoint of both lines. Okay, that's one way you apply it. All right, Lily, you mentioned something. I brought up the first part of the lesson. Guess what? There is a second part. Does it get harder? I don't know. All right, so far these are the problems you've been going through. I've been giving you endpoints. I've given you 2 endpoints. All right, you got endpoint here and an endpoint here. And your goal in these problems was to find the, do you guys remember what you've been doing on all these? You've been finding the midpoint. Good, midpoint. And that's right there, okay? You're finding the midpoint. That's what you've been doing so far in all these problems. That's the first type. There's a second type. The second part still deals with the segment. Oh, that's nice. That has 2 endpoints. And we'll eventually have a midpoint. These problems, I'm going to give you 1 endpoint and the midpoint. So I'm going to give you 1 endpoint and 1 midpoint. So what do you think you have to find? The other endpoint. And actually I should put find, just so you know what to do. Find the other endpoint. So find that other endpoint. Okay? Do you see how they're not the same problem? One, you have to find the midpoint. One, they already gave you the midpoint. You have to find the other endpoint. So we looked at these problems. Now we're going to look at these problems. And if you look on page 372, I'm going to show you how they can describe that for you. Okay, so 372, look at the instructions to numbers 8 through 11. Find the coordinates of the other endpoint of a segment given 1 endpoint and the midpoint M. Do you think that means something? Yes, the instructions mean something. Okay, look at, we're going to do number 9. Page 372, number 9. All right, does anyone know what the endpoint on number 9 is? It's got to be this one because the instructions say so. Go ahead, Carrick.
-3, 7.
Whoa, why can't it be -7, 7?
Because that's the midpoint.
How'd you know that's the midpoint?
Because it says it's the midpoint.
Yeah, what's the midpoint given with a letter? It's given M. So that means B has to be the other endpoint. Okay, so you got it. So we have the endpoint. So here, this is number 9. The endpoint is the -3, 7. And your midpoint, wait, they already gave me a midpoint, huh? Okay, -7, 7. And I have to find the other endpoint. Question?
Does M stand for slope?
No, and it's a capital M. So it's different from that lowercase m. Yes, good question. So it's talking about point M, which is different from lowercase m. All right. You know how to work these out? Almost the same exact way we worked out the first problems. Okay. Does anyone know how to get that x coordinate? Do you remember how to do that? And I'll put it right here. You do x sub 1 plus x sub 2 divided by 2, and that's going to give you your x coordinate, right? You remember that? Okay. This x sub 1 and x sub 2 represent the 2 x coordinates for the end points. And this represents the x coordinate for the midpoint. you understand what I'm saying? Endpoints, midpoint. Do we have both endpoint x's? We have one of them, right? It's that guy. So which one of these should be replaced with -3? Which one do you think?
Either one.
It doesn't matter. Because what property is going on here? That I can use x sub 1 first, x sub 2 first, or vice versa. Commutative. I'm just going to make x sub 1. -3. All right. Do I know what the midpoint x is? It's -7. So they already gave me this part right here. Can I solve for x sub 2? Is that possible?
Yes, you multiply everything by 2.
Multiply both sides by 2. I get -3 plus x sub 2 equals -14. Then what do I do? Add 3 to both sides. I get x sub 2 equals -11. So do I know the coordinate of my other, do I know the x coordinate of my endpoint? Yeah, it's -11. How in the world do I find the other coordinate? Hey, just do it with the y's. So I got y sub 1 plus y sub 2 divided by 2 equals y. Okay, do I know one of those y sub 1, y sub 2's? Do I know either one of those? Yeah, it's 7. So Mr. A, which one should I replace with 7?
First.
All right, that's fine. First one. Could you have done the second one?
No.
Yes. All right. Do I know what this y is? Do I know what the midpoint y is? Yeah, it's also 7. So in this case, it made it easy. Can I solve for y sub 2? Mm-hmm. Carry the 5, divide by this, plus that. Yeah, it's going to be what? Yeah, because what's 7 plus a number averages to be what number? 7. So, okay. But anyways, if you multiply both sides by 2, you'll get 7 plus something equals 14. Subtract 7 from both sides, you get y sub 2 equals 7. So many ways to think of it. Okay, to see if you guys are paying attention. My first volunteer. Autumn, what does this point represent? The other endpoint. Okay, not the midpoint. Did we already get the midpoint? Yeah, they already gave it to us. Did we get another endpoint? Yeah. So these two endpoints, and that's the midpoint. And I'll sketch this real quick just to show you what we had. The first point is -3, 7. -3, 7 is like somewhere over here. This one's -7, 7. This is one endpoint, B. This is the midpoint, M. And I'm trying to find what's that other endpoint. So what did we say it was? -11, 7. So -11, 7 would be about here. Do you see how that works? And that's other endpoint. We'll just call it E. Do you guys see how you kind of get what we're doing here? Okay. Basically, you're doing the same process. Sometimes you have both of these. Sometimes you only have one of these, but you will have that as well. So you always only have one variable that you need to solve for. And here's what you got on this particular problem. All right, let's see you try number 8. I want you guys to do number 8. Find the other end points. I want an end point. I don't want the midpoint. They already gave it to me. 8. Oh my. Does anyone know why I put negative 1.5 here instead of right here? Because I thought we did it in here. So, Jenna? This is the midpoint x. This is n endpoint x. I don't know what the other endpoint x is. So did anyone get what the other endpoint x coordinate is? Abby? For the x, sorry, I lost my spot. Super close. And I think I know what happened, but anyone get it? Yes, Alex? Negative 6. I'm not sure. Did you multiply both sides by negative 3? Or okay, did you get this right here? Did you guys get this?
Yes.
Okay. What do you do to both sides? Multiply by?
2.
So you're going to get 3 plus x sub 2 equals negative 3. And then you have to subtract 3 from both sides, and you're left with x sub 2 equals negative 6. Because negative 3 multiply. Okay. All right, so you got your negative 6, and then I need that y coordinate. Clear?
4.
Positive 4. So multiply both sides by 2, you get 6 plus y sub 2 is equal to 10. Then you subtract 6 from both sides, and you get y sub 2 is equal to 4. That's how we got that 4. How many of you got this? Ready? Maggie? What's this called? What's that point called? It's one of the endpoints. Carrick, what's the midpoint
Like
of this problem?
negative 1.5. Okay.
Huh. What's the other endpoint? Maggie gave me one endpoint. I need the other endpoint. Jenna? 3, 6. Okay, so you got to know what they give you in order to know what you're trying to find. Because what's going to happen is some of us, possibly, are going to find the midpoint of this. So you're going to find the midpoint in between the midpoint and the endpoint. The quarter point. Is that what we wanted? Have we talked about the quarter point? Not yet. Okay, that is it for this assignment, this lesson.